Have you ever wondered why large passenger planes store fuel in their wings? At first glance, it would make more sense to use the space inside the fuselage. But in aviation, every decision is calculated, down to the smallest detail, and storing fuel in the wings is one of the smartest engineering choices ever made. Before we go further, subscribe, because the next part will completely change how you see airplanes. Let's continue. To understand this, you first need to know one thing: center of gravity. It's the point where the entire weight of the aircraft is balanced. If it shifts too far forward or too far back, the plane becomes unstable. It needs more control input, burns more fuel, and puts extra stress on the systems. That's why engineers carefully distribute everything on board: passengers, cargo, equipment, and especially fuel. Because fuel can weigh tens of tons. So, why are wings the perfect place for it? Because that's exactly where lift is generated. When fuel is stored in the wings, the center of gravity stays close to its optimal position, even as fuel is being burned. The aircraft remains stable, more efficient, and requires less correction from pilots and automation. But imagine the fuel was stored in the nose or the tail. As it gets used, the center of gravity would constantly shift. The plane would behave differently throughout the flight, become less predictable, and require constant adjustments. That would make flying more complex and less safe. Storing fuel in the wings solves all of that. There's another reason why fuel is stored in the wings: space. Because aircraft need a lot of fuel. In large airliners, we're talking about tens of tons of jet fuel, and that requires a massive amount of volume. But inside the fuselage, every centimeter is already taken: passengers, luggage, cargo, systems, structure. There's simply no room for huge fuel tanks. And this is where wings become the perfect solution. Because most of the wing is actually empty space. Structurally, a wing is built from strong spars, ribs, and skin, designed for strength and aerodynamics. But inside, there's a lot of unused volume. And engineers realized something powerful: the wing itself can become a fuel tank. Not tanks inside the wing, but the wing itself. Fuel is stored directly inside its sealed structure. It's efficient, it saves space, and it doesn't take away from passenger capacity. That's why in commercial aviation, fuel is stored exactly where it makes the most sense: in the wings. But here's the part most people don't realize: fuel doesn't just sit in the wings, it actually makes them stronger. First, the design. This isn't like a car fuel tank. In an aircraft, the wing itself is the tank. Inside, it's divided by multiple ribs with small openings between them. This allows fuel to flow, but slowly. So during turns, turbulence, or climb, it doesn't slosh violently. It moves smoothly. That's critical for both safety and structural integrity. But now, the key point. When a plane takes off, it's at its heaviest. Fuel, passengers, cargo, everything is on board. Lift acts across the entire wing, while most of the weight is concentrated near the fuselage, so the wings naturally try to bend upward like giant springs. Now imagine the wings were empty. They would flex more, experience higher stress, and wear out faster. But when they're filled with fuel, that fuel acts as a counterweight. It balances the forces, reduces bending, and spreads the load more evenly. The result? Less stress, longer lifespan, safer flight. It's one of those rare engineering solutions that is both simple and incredibly effective. Now let's look at how this works in practice. Take the Boeing 737-800, one of the most common aircraft in the world. It has three main fuel tanks, two in the wings and one central tank located in the wing box, just behind the landing gear. Total fuel capacity is around 20 tons, about 4 tons in each wing, and roughly 12 to 13 tons in the center tank. On short and medium flights, the aircraft usually uses only the wing tanks. That's roughly 7 to 8 tons of fuel, more than enough for typical routes. The center tank is used when extra fuel is needed, for long flights, diversions, or delays. And here's the key rule: If there's fuel in the center tank, it's used first. Why? Because its pumps create higher pressure, so engines automatically draw fuel from it first. Once it's empty, the system switches to the wing tanks. This helps remove excess weight from the center of the aircraft early and keeps the balance optimal. Refueling is also smart. Fuel enters through a single point under the right wing and is distributed automatically. First to the wings, then to the center tank if needed. Each tank has two pumps for redundancy. Even if one fails, fuel supply continues. And for safety, modern aircraft use nitrogen systems to reduce oxygen inside the tanks, making fuel vapors far less flammable. All of this together, fuel flow logic, tank design, redundancy, and safety systems, makes the aircraft incredibly reliable. So, in the end, fuel in the wings isn't just a tradition. It stabilizes the aircraft, saves space, reduces structural stress, and makes flight safer. What looks simple from the outside is actually a highly engineered system working perfectly in every flight. And if you enjoy content like this, subscribe. We break down complex things in a simple way.